We're studying IGCSE physics. This is the third class in magnetism transformers. Now, fine. Let's recap. In the last class, we studied all about that VP, IP is equals to VSIS. The next thing we learned was that VP, VS by VP is equals to NS by NP. Okay, these are the two equations you need. Now, what are these equations for? Write them in your notebook. I'm telling you what they're needed for. VPIP is for power, finding power in transformer. Guys, can you hear me? Yes?
Yes, sir.
Okay, so power and let's say this one is about finding turns. Now, you can use these equations for a lot more than this, but there's just a general thing about power in transformer and turns in transformer. Fine. Now, the next thing we're doing today is looking at step down, step up transformers. We saw what they are. I think I've given you the definitions in your notebook. Step down and step up transformer. Shreya, tell me what is a step up transformer?
A step-up transformer is when the primary coil has
turns in secondary are less than turns in primary. Ayan, Neha, Anas, write this in your notebook.
So?
Write this in your notebook. Turns in secondary coil are less than turns in primary coil. And in a step-up transformer, the opposite happens. Turns in secondary coil are more than turns in primary coil.
I'm really sorry, my internet's been acting up today. So
yeah, that's okay. That's okay. Just write this in your notebook if you haven't already.
Okay, one sec. Let me see.
There's one more line you need to write here, which is power current in secondary is less than current in primary. And the opposite is true for this. Now you have to write the whole thing. This right here is for 2 marks in your exam. Now quickly get this over with so we can start practicing questions.
All right, one sec.
Sir, are you speaking?
Yes, can you hear me?
Yeah.
Now,
Yeah,
have you finished writing this?
Yeah.
Now there's a third equation on the top, write that as well. Efficiency. Efficiency is useful output power divided by total input power into 100. Now this is everything you need from transformers. There's one more thing which we have to do in a second.
I'm done.
Done? Okay. Now I'm going to show you the book. Can you see the book, Neha?
Yes, sir.
The 9.12, 9.12, power across the country. Now please read this, the objective.
Yeah. Objectives to describe the main features of a cross-country power transmission system, to explain using calculations why very high voltages are used.
Or why very high voltages are used. So, okay, what they're saying is, when you're transmitting the power, why are high voltages used? Look here. Now, Anas, look over here and tell me, what do you see right here? What is this?
Power station.
It's a power station. Just a second. Now, if you look over here, you have the power station. Yes? Now, Ayan, read what we have here.
Power station, transformer step up,
Then,
step down,
step down,
transformer
transformation
substation, step down.
substation. Yeah. And
Yeah.
then this guy goes till, what is over here? Transformer.
Transformer substation, step down, transformer
Step down.
substation, step down, transformer substation, step down.
All right. So what's happening here is, let's again, Neha, work with me. Where is the energy coming from?
Yeah,
Where is it starting? It starts here. That's the start. Where is it starting? At
Yeah.
the power station. Yes.
Power station. Yes.
And then what do you have right after the power station?
The transformer.
Transformer, not just the transformer. Which kind?
Step up.
Step up. Now forget the substation part. Forget the transformer part. We care about step up or step down. Now if we have a step
Yeah.
up transformer, so energy comes here. Let's say energy is coming here with perhaps like this. Just a second, like this. Now this is the energy you have. It's zigzag right now, right? And as soon as it goes here, it becomes a lot more voltage. That's the voltage. And then this right here, then it decreases a bit, comes here, and then it becomes very less when it goes inside your house, becomes even lesser like this, and the whole thing is now very less vibrations. Now look here, if you look at the vibrations here, or if you focus on how the electricity is vibrating right here, you will realize that there's a lot more vibration over here, yes, in this area, than over here. Yes. What can you compare? Now, Shreya, I want you to compare these three regions. Where do you think has the more, let's say, fluctuation?
The top one, when it's going from the step up transformer to the step down transformer.
Yeah. Okay, so a lot more. What do you say? Fluctuations there. Now, this fluctuation, and
Yeah.
what I want you to realize is voltage. Voltage is high. Okay, so realize wherever you have more fluctuation, just imagine that to be high voltage, and over here we have low voltage.
What does fluctuation mean?
Fluctuation means vibration like this, up, down, up, down, up, down. Yes.
Yes.
I'm just using this to show you. You don't have to remember the fluctuation. You have to remember high voltage. Is that clear? Now, where do you have the highest voltage? You have the highest voltage if you focus here right now. You have the highest voltage here, 400,000 volts. But if you compare it with this guy, at the beginning it was only 33,000. So it went from 33,000 to 400,000, then decreased a little bit, but then it decreased severely from 132,000. It went to 33. 33,000, 11,000, just 230 volts. And that is what you're getting in your houses, 230 volts of power. Okay, so what we're realizing is when the power comes from the station, it has a good amount of voltage, but when it's traveling, we increase the voltage. Voltage is a lot more, 400,000. It's traveling from the power station to your house. And then from the power station, we decrease the voltage. From your at your home, we decrease the voltage. Let's start reading from here. Start reading from here, Ayan. Power.
Power of the AC main is generated in power stations, transmitted through long distance cables, and then distributed to customers. Wait, sir, where did I read them?
You have to read up till here. Voltage.
Typically, a large power station might contain 4 generators, each producing a current of 20,000 amperes at a voltage of 33,000 volts. The current from each generator is fed to a huge step-up transformer, which transfers power to overhead cables at greatly increased voltage.
All right, stop. Now, Neha, read this, the highlighted part.
Yeah. Overhead cables are. Oh, wait.
Stop. Start again.
The current from each generator is fed to a huge step-up transformer, which transfers power to overhead cables at a gently increased voltage.
Not gently,
Sorry,
greatly.
greatly. Sorry.
So why is it so high? Why do we have to increase the voltage when we're transferring? Now, have you seen these towers in the streets, in the roads, highways and stuff? Have you ever seen a tower like this, right?
Yeah, I have, but like not that frequently. Like
Not that frequently.
yeah, there's
Okay.
one in my colony.
I
so
have,
yeah,
sir.
You have? I'll show it to you. Just a second. Perhaps.
There's a specific term for it as well. I just don't remember.
Right. It's called overhead. These are called overhead cables. These cables are called overhead cables. Okay.
For the tower, there's another term.
Right. We'll talk about that's called a transmission tower. But electricity transmission tower, we don't need to know that. Let's just say transmission tower. And we have overhead transmission cables. This is what they look like. The thing is, the voltage in these guys are very high voltage. Okay. Okay, that's what's happening. But before this, we have our power station. Let's say, let's make a chimney. This is our power station. It's connected to it, power station. The thing is, the power station does not make so very high voltage. It makes just a little high, not that high. It's significant, moderate, let's say. Now this right here is your step up. Let's call this a step up transformer. Step up. Now what's happening is the power station has low voltage, or let's say moderate voltage. Then we have step up, and after the step up, what usually happens is, or what is supposed to happen is, moderate voltage will increase to let's say very high voltage, and then it is transferred in your power cables, right? The overhead cables, and then this is connected downwards to another transformer, which is called a step down transformer. And then you have your house. Now what we realize is when it's being transferred from the power station to your house, it is being transferred at very high voltage. Now I'm repeating this word because it is important. Very high voltage when it's being transferred. And when it reaches your home, there's a step down transformer which makes it low voltage. So that you don't get electrocuted when you touch Let's say when you plug in your appliances, they don't get let's say short circuited. So this is how it works: low voltage, high voltage, again low voltage. Now, I need you to write this in your notebook, this part, especially this. Now, before I move on, ask me any questions if you have anything. Any questions here?
I can see.
Sir.
Oh my God. That's not good. That's not a good thing, right? Now can you see it?
Yes, sir.
So guys, this is not acceptable because if you're looking at the whiteboard and I'm drawing something or speaking, you have to tell me if you can see the whiteboard or not. Right? Stop me,
I
write
thought
it in
you
the
were talking on
chat.
the book.
No, I'm not talking about the book. Yeah. Now can you see the whole thing? Let's start again. You have
Yes,
your
sir.
power station, moderate voltage. Okay. Then you have a step up transformer, which makes this moderate voltage go very high. Neha, what's happening here in the first section? Tell me. Neha, can you hear me? The mic's off, guys are going outside. Whoever has a mic's off, they're outside. Now it's on. Now can you hear me?
Yes, sir.
Yep. Yes.
Okay, so power station. What is the voltage at power station? Tell me. Write it in the chat, all of you. What is the power station what is the voltage at power station? This is a question. Answer in the chat. I need 4 answers. I've gotten one only. I don't want a number. I want, is it moderate? Is it high or low? You have 3 options: moderate, high, or low. Okay. Now the answer is written on the board. Moderate. Now try again. What is the voltage at the power station? Moderate, high, or low? It is moderate. Write it in the chat. I've gotten Ayan's answer. Okay, correct. Shreya, Neha, Anas, I need your answers.
Did you not get mine?
No, I haven't. Shreya, your answer is wrong. It's not low. It's moderate.
Yeah.
So write it in the chat again. What is the voltage at the power station? I've gotten 3 answers. Neha, I haven't gotten your answer. Now we're moving on to the next one. What is the voltage in overhead cables? Or the question is, what is the voltage during transmission? I don't think I can hear you, Neha. No. Now I'm going to write it here. Power station. Write it in your notebook. Power station, moderate voltage. Transmission, overhead transmission cable. Very high voltage. Home, low voltage. Now write it in your notebook and give the title transmission of electricity. Tell me when you're done writing. Now you should add these things in the middle. These these arrows. And in front of these arrows, you have to show step down, step up, and then we have
Answer.
done. Wrote everything. Step down, step up.
Yep. Oh, wait, no, I didn't write that.
If you're done,
Answer.
done. Shreya, Anas.
Done, sir.
Okay.
Almost.
Okay. Almost. Now I'm going to ask you questions, Shreya and Ayan, if you have written it. The first question, whoever answers this first is a better student. What is the voltage in, are you ready? What is the
Yes, sir.
voltage in transmission cable?
Very high.
Very
You have
high.
to, yeah, you have to write it in the chat.
I'm better.
Write it in the chat. Nobody wrote it. 0 marks, everyone. Next question. Next question is
No. Whose answer do you get first in the chat?
Ayan. This one, this time.
If I typed it with a bit of frustration, I apologize for the spelling mistakes.
Okay. Right. Now, what is the voltage in ohms?
Low.
Anas gave the first answer. Anas is a better student. Okay. Now, last one. What is the voltage in ohms?
In
Ohm.
In homes.
And finally, what is the voltage in the power station? Right. So first, Anas, then Shreya, then Ayan. All right. I think that's clear. Now let's finish this up. Neha is here, right? Neha, you can write in the chat at least. Can you hear me? Now fix your microphone quick. Now the first thing is, why is power, let's say electricity, or why is why is high voltage transmission used? Write it in your notebooks right now. This is a question. I'll tell you the answer. Now, since the answer is this, since P is equals to VI and I V is equals to IR, then P is equals to I square R. Next thing,
Is there I squared or
I square R, yes. Now there's the answer. I hope you finish this and tell me when you're done. First, Neha, turn your mic on. Try saying something. Perhaps I was able to hear you in the beginning. Guys, please finish this quickly because we're running out of time. We have to do questions.
None.
Done, sir.
Done. All right. Now I'm going to ask you this. Done. Fine. I'm going to ask one of you. First, let's say I'm making two teams here. It's Shreya and Anas, Ayan and Neha. All right. Now the question is, first question from Shreya and Anas. Only one person can answer at once, right? And nobody can answer in the 2 times in a row. Is that clear? Rules clear?
Okay, so alternating. Okay.
Alternating. Nobody can answer twice in a row, and only one person can answer at a time. First question from Shreya and Anas. What is the voltage used in transmission? Who's
I'm gonna
answering?
answer Anas. Should I
Go on.
answer or
Yes, your choice.
Yeah.
Whoever. Yeah. Okay, you have to say it out to me, right? You don't have to write it.
okay. Sorry. High voltage is used
High
in
voltage
transmission.
used in transmission. Ayan and Neha. Neha, you can type. Now, your question, Ayan, are you ready? Both of you.
Yes, sir.
Now, you tell me, what is the relationship between power and current?
P equals to VI.
That's the equation. Okay. But okay, are power and current directly proportional or inversely proportional?
Oh, they're directly proportional.
Directly proportional. Right. So both of you got one point each. Shreya, Anas, your next question to you. Why do we reduce current in transmission?
Anas, answer, please.
Reducing current in transmission reduces loss of power in transmission due to heat and resistance.
Wow, that's amazing. Good, 1 mark to you. Yeah.
Hello, sir.
Yes, I
Which are
can.
the answers on the board?
Can you hear me?
Yes, I can hear you.
Okay. Yeah. So sorry to interrupt, but like my network is really glitchy right now, so I could not hear you. What are we doing?
Now, what are we doing? We are doing transformers 3. Now we're looking at
Competition.
why are we using high voltage transmission in what is the benefit of using high voltage transmission, right?
Okay.
Oh,
Okay.
so write everything that you see in the board right now in your notebook.
Okay.
Now, next question from Ayan. Then the question is, Ayan, tell me an equation which has power, current, and resistance in it.
V equals to IR. No, wait, P equals to IR squared. I squared R.
I square R. All right. Another point. So yeah, you guys have a draw right now. Next question, Shrey. The question is, you tell me what causes resistance and heat in transmission?
The in transmission, right?
Yeah.
So when you reduce the current, or when the current gets reduced, the heat and resistance get reduced.
So what causes heat and resistance in transmission? What is the cause of heat and resistance?
The high energy, the high voltage.
No. This is how it works. Wrong answer. High current causes heat and resistance. High current causes loss in power due to heat and resistance. Write this in your notebook. Tell me when you're done, all of you. Ayan, Anas, Shreya, Neha.